I am going to start with overall perspective of what is Hadoop. Some may you have an idea of Hadoop. I am going to let you know what is Hadoop. Before going up with what is Hadoop, let me discuss what is.
Okay.
Yes.
So Ram, you are asking me or?
No, please.
Okay. Okay, I explored some of the Hadoop big data. Like Hadoop is like to do the analytics in the big data environment. For example, previously we have one server or computer. We are loading the data in the storage, and we do the analytics with the processor.
Okay.
But later than that, the data is getting
More.
more than more and more.
That you need
Yeah.
to go for is infra. You can go up with this Hadoop for your storage.
Yeah,
You
we
can,
got the LVM concept in the Linux,
yeah,
suppose, I think so.
large volume management.
Yeah. Yes, logical volume manager. So in the logical volume manager, we can extend the storage scalability, and we can store the data. But for processing is still we have under only one processor, but disk level we can scalability with the use of LVM.
Here,
But for extend the processing capacity also, we are going to Hadoop. Just correct me if I am wrong.
yes, correct. So for storage and processing in a distributed manner, you need to go for Hadoop. That's good. Now the agenda for today's session, we are going to start a discussion on what is big data, then and what is Hadoop. Then while dealing with big data, we are going to deal with today's traditional way of data storage and processing, RDBMS versus big data. What are all the things that we couldn't able to done with RDBMS for today's requirement, and how these things can be done using this big data and Hadoop together associated. In that sense, we need to have a discussion on the differences in terms of the major characteristics between RDBMS and big data. And we are going to discuss about overview of Hadoop architecture. What is distributed processing? What is distributed database? So overall view of Hadoop architecture. And we are going to discuss about some of these Hadoop ecosystem components. What are all the associated ecosystem components for data crawling, data storage, data processing, data visualization, how to make coordination, how to schedule the jobs to run automated, like all the associated ecosystem components. So this is the agenda for today's session. Let me start with what is big data. Each and everyone, big data is a buzzword in today's IT industry. Each and everyone is talking about this big data. Can anyone let me know in terms of your perspective, what do you mean by big data, please? Yeah, big data, which is nothing but in a layman point of view, which represents today's digital data. Okay, today's digital data is termed as big data. Okay, this is a layman definition. Let me have a more technical definition of big data. Everywhere it is computerized. Our entire world is mechanized. Whether starting from a grocery shop down to a huge exploration, scientific exploration, we are making use of computer in a more detailed manner. And all the information that we need to store and process are digital informations. And those informations are of a very huge volume in size. Okay. Traditionally, we make use of our RDBMS tools like Oracle, MySQL, SQL Server for data storage and for data processing. Okay, we make use of these tools: Oracle, SQL Server, MySQL, okay, etc. Informix, Ingress, etc. for data storage and data processing. So here, to accommodate this today's digital data, which is of very huge volume in size, your RDBMS is lagging in certain perspective. Okay, let me first start with the discussion on what are all the perspectives you can't make use of the RDBMS to store what we call as big data, and how this thing can be done using this framework called as Hadoop. Big data is a generic terminology which represents today's digital data, which is of huge volume, which is generating with very high velocity, which is of different variety, and another key feature is veracity. Let me have discussion of all those features. All the features togetherly constitute what we call as big data. Hadoop is a tool which is nothing but a framework. It is a constituent of several components which is used for storing and processing what we call as big data. Okay, so the term big data is to represent a generic terminology which is used to represent the today's data. Then Hadoop is a tool which is a framework which is used for storing and processing what we call as big data. Okay, so here if you have a generic definition for big data, here is the definition. Any data here refers to, it may be a structured data, it may be a semi-structured data, or it may be unstructured data, which is beyond two things. One, the storage and processing capability of a single centralized database architecture, which is the architecture currently followed by your traditional RDBMS. This traditional RDBMS follows this single centralized database architecture. Your data will be stored on a single machine called as a server. You have database here. Okay, so you can't able to store the data beyond this. This is the architecture currently followed by RDBMS. So any data which is beyond the storage and processing capability of single centralized database architecture and possessing the following four characteristics: the volume, amount of data that you need to store is minimum terabyte, petabyte, zettabyte, etc. Then the rate at which the data is generated, that is velocity, minimum terabytes per hour. The amount of generation of data is terabyte per hour. And third characteristics in terms of variety. In terms of variety has been concerned, we have structured data, semi-structured data, and unstructured data. The structured data is the one data stored in forms of rows and columns in your table. In your RDBMS, you may create a table, employee table with the employee number, employee name, and salary. So, and you have a data recorder here, employee number, employee name, and salary like thing. The data is stored and accessible in forms of rows and column format. This is an example of structured data. A semi-structured data, which is nothing but your email, your PDF, they may have some partial structure. They may not have a full structure as that of your employee table. Here you can able to access any information by specifying the row comma column intersection. If I want to access the name Arun, I can specify second row, second column. All the records will have the same number of columns. If you don't have any column value, it will be replaced with a null value. So this is an example of a structured data. Whereas if you took a PDF or if you took an email, it may have a structure, but the structure is not a well-defined structure as that of your table. It may be a partial structure. That's the reason why it is termed as a semi-structured data. Then unstructured data, which is nothing but your image, your audio files, your video file. These are all examples of unstructured data. If we took into consideration today's digital world, here almost 80% of today's data is coming under a semi-structured or unstructured. Only 20% of data is coming under your structured category. Okay, this is the logic. This is the statistics associated with today's information. Okay, what nearly 80% is coming under the semi-structured and unstructured. Only 20% is coming under the structured data. Okay, here your RDBMS, such as Oracle SQL Server, will have a support only to this structured data. Now we have several additional tools using which you can have a support to this semi-structured and structured, but it is not in a full manner. You can't have support to today's 80% of data, that is semi-structured and structured. That is one of the major drawbacks associated with your RDBMS tools like this. It supports only structured data. That is the first difference between making use of your RDBMS and your big data. Okay, now, so this is structure, semi-structure and structure. Okay, any data. Here, big data refers to all the three data, the structure, semi-structure and structure data, which is beyond the storage and processing capability. Why? Which is beyond the storage and processing capability of a single centralized server. Here, the thing is that if you have a single server for your storage, you can't be able to store beyond this server. Okay. So if you imagine if your server capacity is 4 terabytes, if you want to store data within 4 terabytes, then that's okay. If your data size is 10 terabytes, here in this case, you can't able to make use of this server. What you need to go for? You need to go for a storage box like a sandbox or a NAS box, either a storage area network or a network attached storage, under which you have multiple storage. Here you can store your data and your application may be running on the server. Then whenever the data is needed, the data need to be moved into the server where your application is running and it got processed here. So here this is another way of having your data in a box and running an application in your server and moving the data towards the server where you are having your application. This works good if the amount of data that need to be transmitted is less in number, in terms of megabyte or in terms of a few gigabytes. Here, in terms of big data, the volume here starts with the minimum terabyte and petabyte. If you have this terabyte and petabyte of data stored in a sandbox or NAS box, and if it need to move towards the server, it will be a time-consuming activity. It took days for transfer data from your storage box into your application server. So that is the second drawback associated with having your data in a separate storage and moving the data into this server. Okay, that is in terms of the volume of storage as we concerned. So because of the above said reason, this single centralized database architecture is not best suited for what we call as big data, which may have a best suited solutions for your traditional RDBMS, which involves data storage and processing in terms of terabyte and very few terabytes, gigabytes and few terabytes. Whereas in case of big data, it starts with the minimum of terabytes and petabytes. That is not a supported solution. Okay, so now we will make a discussion on the above said characteristics between RDBMS and what we call as big data. Okay, so let me first start with this volume. RDBMS support gigabytes of data and up to very few terabytes. So up to 1, 2, 3, 5, 10 terabytes of data, then you can make use of your RDBMS because of its single server architecture. Whereas the big data, it starts with the terabyte, petabyte and zettabyte. For example, if you take any application, let me take a Facebook. One day Facebook is generating 500 terabytes of data. If you take a social networking like Twitter, one day it is generating almost 200 terabytes of chips. If it is a 1 hour, at the average 25 terabytes of data and at the average 10 terabytes of Twitter has been developed. Any application, Twitter, Facebook, any, for example, if you want to go for work with this weather forecasting or scientific exploration, or if you are going up with some applications which let us know what is the price of a stock, almost all sort of applications deals with data in terms of terabyte. Okay, so here your RDBMS doesn't support this sort of applications which need terabyte of storages. Okay, so for that we need to have a separate architecture which was provided by Hadoop framework. So the second character.
Ram.
Yes.
Ram, sorry to interrupt you.
Yes, no issue. At any point, my request is at any point of time, if you have any doubt, kindly you can intercept me. Once the doubt has been clarified, we can proceed further.
Okay.
Yes.
So, see, basically, when you say that it's a question of handling the data in terabytes,
yeah,
that is also the reason you mentioned that RDBMS won't be able to handle.
Yeah.
But RDMS is like a technology, but if you see the tools in the market, if you take an example as Teradata is also one which is also like handles terabytes.
But
it's also a scalable application.
Yeah.
Scalable technology. But why is that? Do I need to mandatorily go for big data?
Yes.
What is that? It is.
Please wait a while for 2-3 minutes. You will get the answer.
Okay.
Yeah. You will get the answer. Yes. Now, in terms of velocity, the rate at which the data has been generated, being it is a single server, if the data is approaching the server with the rate of gigabytes per hour, the server could able to handle this workload and it can do the needed processing. Whereas here in case of big data, let me take an application which involves this Amazon. Amazon is launching some reduction sale, a New Year sale or Dhamaka sale. Similarly, Flipkart is launching some reduction sale. At the time of launching, so this Flipkart server is flooded with the request, which may be terabyte per hour. Okay, number of requests that is approaching to this server may be terabyte per hour. If it is a single architecture as that of your RDBMS, it couldn't able to withstand this much of request. So here comes the concept of the distributed computing, which is followed by Hadoop. Therefore, in terms of velocity has been concerned, the data generation speed is termed as velocity if it is RDBMS, and it can able to withstand if the velocity is gigabyte of transaction per hour. Whereas big data, it starts with minimum terabytes per hour. One such example is example approaching Facebook, Twitter, or even sites like e-commerce sites like Flipkart or Amazon. Okay, so that is the second differentiation between RDBMS and big data. The third and most prominent difference is variety of your data. In terms of variety, as we already told, we have structured data, semi-structured data, and unstructured data. RDBMS supports structured data. Here, this big data need to have a support for structured data, semi-structured data, and unstructured data. So here in RDBMS instance, I am talking with respect to Oracle, MySQL, etc. Okay. Now we have a data appliances as of you conveyed, like Teradata, Exadata, Greenplum, and etc. We will talk about these things. So it supports only structured data. A big data is one which which is not only a structure, it is a semi-structured and structured data. And fourth and important characteristics, veracity. Veracity refers to reliability of your data. How far your data is reliable. So let me take a RDBM. So we take a table employee which contain a row employee field employee number which is declared as integer. So if you insert value 1, it will accept. If you insert A1, whether it accept or not, it won't accept. Why so? Because it is violating the schema of that particular table. The schema is defined as an integer, whereas A1 is not an integer, it is a varchar, therefore it will be simply rejected. So the data need to be pre-processed. You can't have a missing value. You can't have a inconsistency. Okay, in your RDBMS, there can be have a missing value, inconsistency, irrelevant information couldn't able to be stored. Okay, the data need to be pre-processed. So the data once it's pre-processed, one it is free from the above anomalies, then only you can store and you can able to process on top of it. Whereas in case of big data, you may crawl data from real world sensors, from social networking sites, from across several servers like server logs. Under that sense, you can't able to ensure clear data. Those data may suffer from some anomalies. It may have some missing value. It may have some inconsistency. It may have some irrelevant information. Here, if you want to do pre-processing before storing your data, and it will be a time-consuming process. So the framework, that is your Hadoop, that you used for storing and processing, will have some inherent capabilities to tackle these issues. You can have data with the above said anomalies, but once you store the data, once you process the data, those anomalies can be get dried using some inherent features associated with Hadoop. It itself can able to tackle how to handle the missing value, how to handle this irrelevant information like thing, etc., etc. Using Hadoop ecosystem components, we can do this type of activity. These are all the four major characteristics which differentiates what is big data and what is RDBMS. And apart from that, in terms of architecture has been concerned, your RDBMS, in terms of this big data, the tool that we are going to use is Hadoop. In RDBMS, we make use of the tool like for architecture in terms of database is a centralized architecture. Centralized database architecture. That is, you have data stored on only on a single location called as server. And in terms of the infra architecture has been concerned, it is a client server architecture. You have the server which holds the database, and the user can able to access through an interface called as client. You may have multiple clients. The client simply acts as an interface. The user may submit a request through this client. The request may be taken to the server. It got processed, and the result will be given back to the client. Here, the data storage and data processing, both the thing is taking place only on the server in this RDBMS, which is a centralized client-server architecture. The client simply acts as an interface between the user and the database. It receives the user request, and it will proceed the user request to the server, and the server will process the request and return back the result. The client simply acts as an interface. Okay, whereas in case of big data, the architecture is a distributed database architecture. Also, because if it is centralized, you can't able to scale your data beyond the server capability. So if it is distributed, you can go on making a concept called as horizontal scaling. Whenever the data size increases, we no need to bother about. We can go and add the needed system to this database. That concept has been termed as distributed database. Example, if you have to store 10 terabyte of data, if it is a centralized database, the entire 10 TB of data need to be accommodated on a single server. If it is a distributed, imagine you have a computer with a 2 terabyte of storage. If you want to store 10 TB, now in this case, what you can do, you can have 5 such computer. Each computer is assumed to be 2 TB of storage, and the 10 TB has been split into 2 TB chunk, and it can be stored across all the 5 computers. The computer where we store data here in Hadoop terminology has been termed as data nodes, that is DN, data nodes. Okay, so if your size increases to 20 TB, so if it is this centralized, imagine you have a maximum storage capacity of 10 TB. If the data size increases to 20 TB, there is no other way you can't able to store the data. Also because the maximum limitation is 10 TB. In this case, what solution that we need to go? You need to go for a solution like sandbox or a NAS box that we have discussed. You need to have a storage here, and your application may be running here. You need to bring the data into the server, but it will be a time consuming if it is gigabytes and terabytes of data. So it is not a better solution to handle this increased volume of data, huge volume of data. Whereas here in the distributed database, imagine you have 5 computers which accommodate 10 TB of data. If you want to store 20 TB of data, no need to worry about. What you can do, you can additionally add additional 5 computers. Now you have 10 data nodes. This 20 TB has been split across all these 10 data nodes. The process of adding these additional computers to accommodate the additional volume is termed as horizontal scaling. This is the concept followed by this Hadoop, that is a distributed database. You may have your data stored across multiple computers in Hadoop. That is the architecture. We will have an in-depth discussion of this architecture. In terms of infra has been concerned, here it follows a master-slave architecture. Your RDBMS follows a client server. Here your Hadoop framework follows a master-slave architecture. Here, some machines have been designated as master computers. Some machines have been designated as slave computers, master-slave architecture. So here we are talking about with Hadoop endpoint X. Here we have a computer by name node. We have a computer by name, secondary name node. We have a computer by name, job tracker. Each and every computer will do some actions, some functionalities. The name node's responsibility is to manage the entire cluster. The name node maintains the metadata information about the cluster. The secondary name node, what is the role played by secondary name node? If a name node fails, here in this case, the secondary name node come into existence. It will help the name node during its recovery process. Then the role played by the job tracker is to execution of jobs. Execution of jobs in a Hadoop cluster will be controlled by the job tracker. So these are all masters. We have data nodes as a slave nodes. And we have task trackers. A data node is a separate computer. A task tracker is a daemon which is running on the data node. Okay, these are all the in terms of architectural perspective. Okay, so here you need to have the opposite computers. How many masters? It is mandatory. You can have only one name node. You can have only one job tracker. You can have one or more than one secondary name node. Then the number of data nodes is n in number in a Hadoop cluster. Okay, so here the number of data nodes here depends upon two factors. One, how much of volume of data that you need to store. The second factor, the hard disk capacity of your data nodes. Example, in our previous example, it is assumed that a data node's hard disk capacity is 2 terabyte. Then to store this 10 TB of data, we need 5 data nodes. To store 20 TB of data, we need 10 data nodes. Therefore, in a Hadoop cluster, a cluster is nothing but a group of computers. Here, the number of masters is mandatory to be of 1. And number of slave here is n in number, and the n depends upon the opposite factors. Therefore, a Hadoop cluster will be looking like in the following manner. You have a master, a name node, a secondary name node, a job tracker, and you have the following slaves. You may have a multiple slaves. Data node 1, data node 2, up to n data nodes. On top of each and every data node, you may have a task tracker, a daemon, a background process running, task tracker here. Your cluster, all these togetherly will form a Hadoop cluster. This is the architectural perspective of Hadoop. How a user interact? The user interact through a computer called as HDFS client. You may have multiple clients through which the user will have an interaction. Okay, so this is the architecture of your Hadoop. So in terms of infra, it is a master slave. In terms of its database architecture, it is a distributed architecture. So these are all the major differences in between your RDBMS and your big data. Now it is a time for your question. If you have any doubt, please let me know before